So now let's place our required components from here. So first we will place the voltage source. Okay, press the escape, then the capacitors in order to make the compensation circuit. This is for the transmitter side, and here we are going to place it for receiver side. Okay, then the two coils in the form of inductors, one is for transmitter and the other one is for receiver. Okay, then here you can see that we have completed with our voltage source and with our two compensation capacitors, which will be in series with the two sockets, and then the two coils in the form of inductors. Now let's place the diodes to make a bridge rectifier. Okay, now let's place a capacitor for filtering purpose, followed by a load in the form of resistor. Okay, now these are all the components which are needed to make a WPT system. Now in order to connect them, use this option which will allow us to connect the components using wire. Okay, from here we'll connect with capacitor. You can refer this diagram. Okay, like this part is missing, I will explain at the end. After connecting this part we are not considering an LT spice. The reason will be explained later. So let's connect the other parts. Okay, this is how a transmitter side circuit looks, and when it comes to receiver, let's first connect our bridge rectifier. So this is how our transmitter looks. Now let's connect our bridge rectifier. Okay, now let's connect this one end of the receiver to here, and connect the other end here. Okay, this is how our circuit will look after connecting all the components as per this diagram. Now it's time to specify the value to each component. So let's first start with our transmitter coil. So here you can specify its value. So our transmitter coil value will be taken from ANSYS Maxwell, so which is L1, so it is 125 microhenry. Okay, 125.31 microhenry. So let's put it here, 125.3. U stand for micro in LT spice. Okay, then for L2 we will do the same, like place your cursor near the component and press right button on your mouse, and here you will taken over the value setting dialog. So this is our receiver inductance, which is 125.77 micro, 125.77. Okay. So they are just colliding, so let me just move the values. So here, from here, you can select the move option and move your components or the labels or the values on your schematic. So click here, move, then select our receiver value, which is this 125.77. oh sorry. So okay, let us move the transmitter value to upper side. Okay, and move the receiver value here and the transmitter value here. Okay, now, so in order to match the resonance frequency of these both the circuits, you have to specify the values for these capacitors. So for that you have a specified formula. So here it is. Yeah, so here is the compensation capacitors for series topology. So C1, which is the capacitor at the transmitter side, can be calculated using this formula, which is 1 divided by omega square into L1. Okay, omega is the angular frequency and it can be extended as 2 pi f. Okay, once again I am repeating, omega can be extended as 2 pi f. So then our equation will become as C1 is equals to 1 divided by 2 pi f whole square into L1. L1 stand for transmitter side coil inductance. Okay, so we have the L1, and in place of omega we are replacing it with 2 pi f. Then the question arises here, what is f? F is the operating frequency which we have specified in the ANSYS. Okay, for the same frequency, which is 85 kilohertz, we have to substitute in the place of f. So for this time you have to take your calculus out. So in calculus, if you substitute the values here, like 2 pi into 85 kilohertz whole square into what is the L1? L1, it is 125 micro, 125.3 into 10 to the power minus 6. Okay, so it is coming around 27.9 nanofarads. Okay, so replace our C1 with 27.9 nano. So N stands for nano in LT spice, which is 10 power minus 9. Okay, once again I am repeating how we have get this value for capacitor is using this formula, which is 1 by omega. Omega can be also written as 2 pi f. For f we are taking it as 85 kilohertz, the same frequency which we have specified in the ANSYS for our, during our coil designing. And the L1 stands for the inductance of the coil 1, which is transmitter inductance. Okay, same you have to follow for C2, which is the receiver side capacitor. Okay, so again we are following so it is just around this number to 1 decimal. Okay, so same formula we are using, just replacing the value of inductance from 125.3 to 125.7. okay, so then we are getting the value approx same 27.8 nanofarads. Okay, 27.